Hi there, everyone. The talk today is really going to be more of an introduction to the concept of hardware management systems and really why we should care about them as security professionals. The subtitle, ILO, if it's off to work we go, says more about my sense of humour than the hardware we're particularly going to be focusing. So, first of all, what we're going to be talking about, we're going to introduce what a hardware management system is, or we're going to define it. We're going to talk about how we find them whilst we're pen testing. I'm going to really give you a quick overview of the tools of the trade. If this is familiar stuff to people, apologies. Just trying to make sure everyone's at the same place in the room. And then we'll talk a little bit about what we're going to do whilst we're actually on a penetration test. Firstly, we'll talk about initial exploitation, how you leverage the vulnerabilities, and then what to do with it. And if I've got time at the end of it, do a couple of demonstrations. The first one is basic skills. Make sure everyone knows how to do this, make sure everyone knows exactly what we're doing. The last demonstration we're going to give you with is either really old or really new. And hopefully by the end of the talk we'll have a little bit of a better understanding of which one it is. So fundamentally, why should we know or care about hardware management systems? Basically inside modern hardware there's a whole bunch of instrumentation. And there's lots of interfaces to that instrumentation that allows us to manage the hardware. Not all of them are obvious. Some of them are actually deeply buried inside the hardware itself. You don't have a direct API that gives you ability to do them, to interact with them, but they're there. As professional pen testers, if we don't know about them, or if we don't know about what their capabilities are, we can't exploit them. And more importantly, how do we advise our customers of the security implications of running the environments they want to run? So I'm going to introduce you to some of the more common hardware management systems we supply. This is certainly not an exhaustive list. We're going to talk about BMCs, baseband management controllers. We'll talk about service consoles or service controllers, depending on which terminology or sales pitch you want to read at that time. We're going to look at some specific examples. Intel AMT, which is their active management technology. If you've not looked at it, it's well worth having a poke at. Particularly vPro and KMS. Computrace, which I'm sure many of you will have seen reference to with Kaspersky, and probably the biggest favourite of them all is IP management interfaces. So the IPMI stuff obviously refers to some of the work Dan Farmer has published previously, and hopefully we're going to extend it a little bit and make sure that everyone knows how to make use of it. Another common technology we're going to discuss is a more generic one, which is Lightsout management or out-of-band management. LOMs are provided by a number of manufacturers, Dell, IDRack, HP ILO, Oracle, with various NLOM formats. Supermicro's got a really nice IPMI implementation, so nice it almost becomes a reference client to us for everything else we do. And pretty much any other high-end manufacturer will have their own lights-out management technology. May not be a dedicated card, but it will be there. So talk briefly about a baseband management controller. What is it? It's basically another small computer, generally based on ARM chips, firmware updates, all that kind of goodness around it. And basically what they do is it monitors the physical state of instrumentation within the hardware that you've purchased. So if you've got a nice big sexy server, it's going to have thermal detection in for the CPU, it's going to be running how much power it's running, it's going to be running what the network speed, all that kind of stuff, and all of that will be instrumented inside the system. And there's a very high chance that baseband management controller is sitting there looking at that instrumentation saying, so what? So common instrumentation we see inside of it. Stuff I'm sure you're all familiar with through there. As an administrator, we very rarely have direct access to the BMC. Okay, almost always there is an abstraction layer via an API that actually gives you that access. You won't necessarily have the ability to reconfigure the BMC natively. Things to remember about BMCs is firmware. So it's, on high-end enterprise kit, it's the bit that people don't update. How many times have you gone to a customer and the BIOS has been 2-3 years out of date? How many times has the SCSI firmware got a known, performance impacting issue, but it's not updated because we just don't update firmware, unfortunately, far too often. One of the nice benefits of updating the BMC is it may actually give you improved performance. So one example of that was when with one of our customers, where they were running HP equipment and they were running with a version of the BMC that was a different version to the version running on the ILO card, which meant that the ILO had no ability to pick up the thermal detection inside the kit at all. So when we went into the rooms and tried to stand next to the rack, we were deafened by the fans blowing 100% full blast. As soon as they applied the BMC update, the firmware updates via a LOM pack, powers all the fans came down to normal speeds, and actually the thermal monitoring inside the rack suddenly took over, and it reduced their power consumption then and there. BMCs almost always have direct interfaces into key security components. We'll talk a lot about direct memory access. I'm sure everyone's aware that if you can control the underlying memory inside a server, you can negate pretty much any security control you want to place inside the operating system. DMA is often provided via I2C bus, but also by all the other controllers that we're familiar with in general. Mentioning controllers briefly, you will see things like virtual FireWire instances, virtualized SCSI interfaces, virtual SCSI interfaces, which do have direct DMA, which have DMA access as part of their specification. So it may not be that you have a memory object that is available via the baseband management controller. It may be that you have to jump through another step to do it. And I2C generally becomes a really easy way of doing that. Other accesses they have is raw device access. It can control the disk controller, it can control the disk. Everyone happy? Cool, service controller. Many of the BMC functions will be implemented in a service controller. It doesn't have to be a simple dedicated device, but it often will be. The service controller, service console, service processor, depending on which sales pitch you want to have a look at that time, basically is your user interface to the functionality of the BMC. It may require secondary authentication, so you authenticate to the service processor and then you authenticate to the BMC, but again, it depends on the kit you're looking at. The most common functionality of the service processor is to provide an environment or a shell for us to operate, for us to actually interact with the hardware that we're managing. And typically, if it's available inside the hardware, i.e. you can make the hardware do it, then the BMC, generally via the service processor, will have the ability to do that. It's sort of fundamental to the process that you want to manage the hardware management subsystem. Not all service controllers are accessible. You've all got one in your laptop. ACPI is generally controlled by a service processor. You don't have a direct interaction with it. You ask the OS to refer to the service processor about an ACPI profile, and it will then implement it and then manage that on the box. Different service controllers have different access methods. The most common ones we come across will be serial RJ45. That is pretty old school, but hey, they're still there. Telnet, they're network available, they're network enabled SSH, or some kind of proprietary API. Excuse me, teeth didn't try again. Fundamentally, what the service processor is doing is watching the instrumentation inside the baseband management controller and then performing an action based on changes that happen inside of that. So a simple one is a CPU watchdog, almost always implemented as part of a service console, but basically if the box is hung, it restarts the box. So you can work in conjunction with it. ACPI, we mentioned it earlier, very often service console function, and the whole CPU tuning when you're working on battery or not is using an instrumentation inside a baseband management controller to say where's the power coming from and then making decisions based around that from there. Everyone happy? Lots of nods. It's always a good start. Okay, specific use case. Advanced management technology. Has anyone heard of it? At least 3 people have heard of it, which is always a good start. AMT basically is implemented in a number of places, both the processor and the chipset. And basically it gives you an ability to hook into Intel-specific processors and perform certain functionality. On the later versions, it uses an IP version 6 broker to actually tunnel through your network onto a shared cloud architecture and try and connect to the registered management center. It allows all sorts of good stuff. You can reconfigure it from the BIOS upwards. Supports virtual media, so if you want to boot off an alternate media and go through from there, it's pretty good to go from there. Yes, you can reinstall the OS, and realistically, you might as well think of it as real VNC integrated into the BIOS. It uses real VNC in terms of communication, so fire up Wireshark, you will see VNC traffic going backwards and forwards. From my perspective, the interesting part is effectively it's a reverse SSL tunnel. It's tunneling out to you, you can then connect to it. As long as you advertise yourself as a management center, you've got a very high chance of being able to interact with that bit of kit. Talking about remote KMS Pro, love this bit of kit. Basically, the real VNC variant is not one that's easy to get hold of unless you just connect to the remote KMS environment, in which case it would deliver you a copy of that real VNC client for you to have a play with. If you're seeing any kind of ANT prior to 2013, and it's really hitting in the i7 processor, so it's sort of like newer kit really, but if you've seen stuff prior to 2013, it's likely to be version 6.0, which allows an inbound connection. If it's not configured, it will DHCP on anything on your network. It uses the first NIC inside the hardware to try and connect out to the world, and it needs a password to gain access. The password is explicitly stated it must be exactly 8 characters, unless it's one of the defaults. Hey ho. Newer versions of it reverses the concept, so it now connects back to you. You can advertise yourself as a solutions manager. You can set up your own PKI environment, and by default it doesn't check your certs to go back out. So if you are the first solution manager it's received, it will take your CA and your CRL as being preferred ones and give you a chance to have a play from there. It's advertised as boundaryless connection. So the big selling point from Intel's perspective is that you've got a whole bunch of remote workers that are out there, and one of them has just managed to crash his laptop. You want to be able to redeploy your standard build image across the interweb to this build. I've seen everyone's looking at this as like a really good idea. Yeah? No? Okay. So you can do that. You also have the ability to remotely execute ANT plugins. And the ANT plugins operate inside the ANT framework, which is a driver and kernel level service. So it just basically spits out commands at system level on the box that you want to have a play at. And you can get GUI control if you're really bored and you want to see the abuse that the person's typing. Is it the ultimate red teaming tool? Certainly handy. Wouldn't rely on it though. Everyone happy so far? Some smiles, good. Okay, Computrace. Who's heard of Computrace? Someone's got to have heard of Computrace. Okay, there is a sales pitch. It's not my sales pitch. Basically, Computrace sells itself as being the only endpoint solution that is available on any hardware that you pretty much want to offer it. Computers, laptops, tablets, microphones, yada, 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 all that kind of stuff. And it will basically remain installed regardless of what the user does, including or especially if the user reinstalls the product from there. It's really, really widely deployed. You'll find it in the majority of the BIOS configuration pages of pretty much any hardware manufacturer you want to choose. If you want a list of the two, definitely not two, definitely a list. If you want a list of the manufacturers that support it, that list is huge. I certainly wasn't planning to cut and paste several pages of PowerPoint slides for you. Back in 2010, we were asked by one of our customers to have a look at Computrace. And our analysis of it was pretty in alignment with the sales pitch. It is persistent, even with an OS reboot. Yep. It does allow you to exfiltrate data. I can get my document back when I need it in an emergency. It does support command exfiltration. It's got a really crappy command and control interface. But hey-ho. Our conclusion, it looks and behaves like malware. Our recommendation to the customer, don't enable it, and specifically reject systems where it's been shipped to you with it when it's enabled. Whilst the BIOS allows you to turn it on, and it will tell you that it's turned off, our experience is that is not necessarily 100% accurate. Once it's been turned on, you've got it. Kaspersky, last month. Really nice publication around it. They're absolutely correct. It uses a lot of the tricks popular. They did a lot more reverse engineering into the actual service binaries themselves. And they found that there was a lot of anti-debug and anti-reverse engineering techniques. It's got everything to do, memory injection, process injection, all those kind of good toys that you want on nice security software. Malware. Also, the network protocol is completely clear text, so you just need to watch a couple of communications going backwards and forwards. You'll see the format of the command strings, and then all you need to be able to do is intercept and replace what you don't like. Yeah, no crypto. If you want a full list of exactly what they did with it, that analysis is brilliant. Strongly recommend having a look at it. If nothing else, just get yourself up to speed on some of the capabilities of the hardware management system. This slide deck will be made available at the end of it, so if anyone's desperately trying to scribble down URLs at the moment, don't need to worry just yet. Everyone played with IPMI? Everyone seen it? Some nods, some people looking blank. Okay. What is it? It's a mess. Sorry, it's a really useful bit of kit. So the IP management interface basically says anything you would want to be able to do on the hardware of a box, let's abstract it, standardize it, and make it available across the internet, basically. It allows you to interact with pretty much any hardware you've got, and it does allow you to have a network comms. This lovely diagram is not my work in any way, shape or form. It's on Wikipedia. You can go and grab it if you want. And basically it shows you the structures inside of it. I think what's probably most useful inside of it is the different kind of inputs and outputs and the power that those kind of inputs and outputs have. And then to be aware of the fact that once you've compromised IPMI, you have access to those inputs and outputs. I'm hoping some of you are feeling a little bit more nervous about it. Okay, two widely implemented variants. Up to 2004, it was 1.5. Much more lightweight, not such an advanced concept. 2004, that's when version 2.0 was instantiated via an RFC. And so a quick look about what's inside of this. So inside the 1.5 standard, there is no encryption. Okay, so all your traffic is clear text. It's really useful for hardware management, I'm sure, but hey, go from there. Specific manufacturers did extend IPMI 1.5 to include crypto for certain parts of the IPMI spec. So if you look inside some of the old documentation around manufacturer N OEM, so like Sun OEM or Dell OEM, some of those components will be encrypted inside IPMI 1.5, but it's really not clear when, and it's not really clear how much across the entire enterprise hardware estate that matches. So you may find that under box A that's true, on box B that's not true, despite it being the same manufacturer. Inside IPMI 1.5 standard, there is no console redirection. Boo, hiss. We're going to like that a little bit later on. But it does implement serial over LAN. Serial over LAN is basically fundamentally the same as what would happen if you plugged into a console port on the back of a Unix box. It's a text-only console, so really useful inside Unix, really useful if you want to administer the BIOS, very unuseful if you want to administer a Windows box. So when you're looking at older implementations of IPMI on older Windows boxes, you want to recommend that they go to a nice new version so you can exploit, so that they are maintaining a proper patch management cycle. But there is challenges in terms of 1.5. IPMI 2.0, again, sorry if this is old news to people, but it did introduce encryption. Boo, hiss. Yeah, they sort of got it slightly wrong. It also provided an authentication framework, which we do make use of all the way through. It provided the ability to have different classes of users and different kinds of functionalities between them. So you can actually tag users inside IPMI 2.0 with functionality that's not inside the IPMI 2.0 spec. We'll demonstrate a little bit more about that when we talk about iDrAC as a specific case. It uses a challenge response authentication, which therefore means it needs to know clear text of the password. So almost always, once you've compromised the service controller, if you can have a good look around, you will find those passwords in the clear. It also introduced the concept of console redirection. So we do get GUI console redirection, which is a nice thing. It also supports, in the vast majority of cases, virtual media, although it's not always true. Why do we care? Why do we care? Well, we should care about it because it's everywhere. I mean, fundamentally, it really is everywhere. Since 2004, IPMI has been in almost all enterprise-grade hardware, whether or not you think it's there or not. So if you're turning around saying, that's okay, I bought my 2008 vintage HP system, ProLiant server, but I spec'd it without the ILO card. Happy days. Unfortunately wrong. IPMI will, via the BMC, via the baseband management controller, fall back to the first available network interface. And the interesting thing about this is it doesn't necessarily mean it's the first card that's inside your slot. It's a whole bunch of arbitration that goes through to actually decide what is, in this point in time, the current first network interface. Once that's been accepted, it will then fire up its own IP stack. It will listen to the host stack, so it can go in either shadow mode or dedicated mode. In shadow mode, it will respond to IPMI requests. It will respond to requests for management, even if the host OS is saying no, I don't understand that, I don't believe it. So most of IPMI is running over UDP 63. So the OS basically, the open teeth in, try again. So the operating system is basically saying, hey, I've not got that port open. Port unreachable comes back. However, the client applications are designed to actually cope with that. What will happen is that whilst the OS says not interested, if you actually send valid IPMI queries, the BMC will respond for you. So you get 2 packets coming back. You can watch it in wire traces. I would say fun, but it's not really the case. Why do we need to care about fallback? Well, either people have not specified LOM, or that they've specified LOM and 1 or 2 conditions has happened. We've seen in one case where the heat expansion contraction of it caused a number of the cards in the box to walk their way out of the PCI slot. Basically, they hadn't been installed with the screws holding the PCI cards in. So there's an education process there for the administrators, and also there's a whole bunch of other issues that are going on in terms of those boxes. The other case we often see that it's falling back is actually when you see an administrator that's been briefed around the IPMI 2.0 issues, they've read the Dan Farmer publications, and they've gone, oh, I'm going to remove this bit of kit right now. They've pulled it, they've not understood the fact that the BMC stack is then going to fall back to the primary NIC as enumerated by the BMC. The one thing I will say is that the primary NIC doesn't have to be PCI NIC 0. It is. There's some kind of weird and wonderful enumeration, and too many bits that can change it for me to clarify them all. Lightsout management. Basically, our out-of-band management. Historically, it was only present on high-end kit. That's no longer true, and we've seen it like in really early kit, as in 99, on Solaris kit with the LOM ports, Lightsout management. And that was typically a rollover Cisco-style cable plugged into the back of a serial port. You could chuck a modem on the back end if you chose to. That gave you remote access. You could use that to build the OS. You could use it to jumpstart the OS. You could use it to harden it, configure it. It could be dev console from a Unix perspective. It was all that kind of good stuff from there. Solaris have extended that, and they've implemented a number of LOM formats. ALOM is the older of the 2 that we're talking about here. ILOM is the newest one of the 2. There is ELOM and a few other ones inside of it. But basically, under production kit at the moment, ILOM is what you're going to see day in, day out. If you see an ALOM, it's old kit. You probably want to be talking about hardware life cycles to the customer. Other ones that are really familiar, HBILO, you've probably seen it all over the place. It integrates really well with HP Systems Management homepage. So if you've seen issues in one, there's almost always going to be a corollary inside the other. So it's well worth using that as your guidance to go backwards and forwards. Dell originally did DRack, which was the Dell Remote Access Controller, and it's now iDrag, which is internet enabled. And pretty much every other manufacturer out there has one or more Lightsout management technologies. Get familiar with the kit you see day in, day out, because they're all slightly different, but they're all slightly fun. Primarily, when we see Lightsout management, we're seeing a web interface. And the web interface has got one functionality to do, and to do really well or badly, depending on the way you want to look at it. It's going to detect your operating system and environment and deliver to you management clients that then allow you to interact with the hardware that it supports. So terminology often used is zero installation client. We're talking about an ActiveX control, we're talking about a Java plugin. That client that's delivered to you is actually got all of the smarts to actually deal with the hardware in question. So you'll often find that those are very similar to each other, but they may be bastardized for particular manufacturers in question. Again, watch the network traffic, it's almost all VNC. Advanced functionality, virtual media. I absolutely love virtual media. Redirected consoles, what's going on the GUI, both the OS and the BIOS. And that's pretty much it with Lightsout management. Everyone happy with that concept? Yeah? Nice and quick, yeah? Right, so what do we do when we penetrate it? Well, we need to be able to define a bare minimum of skill sets that we have to be able to achieve in order to effectively assess the security of this kit. We've got to be able to identify it. If we can't do that, we've pretty much failed at step one. We need to be able to identify if there are security defects within the system, and then we have to determine whether or not those security defects are actually there or actually false negatives. And one of the things we'll see when we look at this is that actually false negative detection is one of the bigger challenges in terms of hitting this kit. We have to be able to exploit the security defects. They're there, we need to be able to demonstrate them. And we need to have a good thought about what we're going to do after we've exploited them. How do we identify it? It's sort of in the name of the product, they're hardware management subsystems. We need to look at the management services. The management services are going to be the ones you're familiar with day in, day out. Whoops, too enthusiastic, sorry that. IPMI, we're going to talk more about IPMI, but we're still inside the Lightsout management. We can see SSH, telnet, web services on running on random ports, UPnP, advertising themselves, DHCP with really familiar names inside of it, like ILO hyphen, MAC address from the ILO card, all sorts of things like that, worth having a look at on the network. Sorry. Sorry. PowerPoint, not my strongest point. So we need to be able to work out what the false negatives are and why they like to be included. The most common reason for it is NIC sharing. So if we've got the IPMI, the baseband management controller, acting in shadow mode, where it will respond as well as the OS, if the OS beats the packets back from the BMC, and it's likely to, because your OS is going to be a big, meaty, shiny, enterprise-grade bit of kit, and the BMC is going to be a tiny little ARM processor struggling to read all of its inputs, you're likely to get packets coming back saying port closed. So don't just port scan. You actually need to try and request from these services, particularly if you've got on boxes that are not dedicated LOMs. It's worth going to have a look at. It's scary the amount of times that actually if you use the relevant tools, you actually get responses coming back. Yeah, basically covered that. Nessus is imperfect. Heresy, I know, but it is. Dell iDrag almost never reports as being vulnerable to Cypher 0. We'll talk about Cypher 0 in a few seconds. Yet, in the vast majority of cases, it is vulnerable. When it is reported via Nessus that iDrag is vulnerable to Cypher 0, you've got a case where it's almost a guarantee that the firmware is incredibly old, and there's almost a recommendation to just sort out their hardware firmware updating process based on that one, on that interpretation of that one finding from there. Obviously worth checking it and double checking it with the administrators, but in the vast majority of cases that is the case. What are we trying to find? What are the defects? Well, Cypher 0. We'll talk about Cypher 0 in a few seconds. A lot of the hardware management systems use a channel response process. A lot of them expose the hashes to you. You cannot very often extract the hashes without authentication. And once you've got the hashes, you can crack them and do all that kind of good stuff from there. Attempt anonymous access. IPMI supports both user and null user connectivity. Funnily, to specify null users minus u, quote, quote, minus p, quote, quote. But it's well worth having a look at. So on a recent test we did, we had a management application which basically was a front end to a whole rack of service controllers in the back end of it. The application required you to have a valid J session ID and a valid token client ATH, client auth, to be able to do anything with it. Now, to get a valid Java session ID, we went to the login page, hit enter, and then we had a valid J session ID. It just wasn't authenticated. We could get client ATH via a port scan. Funny enough, in this case, the string, the client ATH string, was just squirted straight back to you when you connected to port 8123. Don't ask me why. I have no idea. We never managed to resolve that one from there. But that basically gave us the two credentials we needed to go and have a play with it. So because we've been playing with the application as a web application, we knew that we could add a new user. And by using the unauthenticated but valid JSession ID and the client ATH string that was being squirted from that port at the same time, we could add a brand new administrator to the box, and then we could go and have a play. Or we just replaced authorized keys on the management website via a file upload. It's well worth going and have a look at the management interfaces and seeing what functionality is there and thinking about whether or not you can exploit it, stepping back. Everyone happy with that so far? Yeah. How do you extract and crack hashes? Metasploit is by far and away the easiest way of doing it. Metasploit will pass it straight to John the Ripper, and it's got a reasonably well sorted default hardware management subsystems credentials list that goes against that, so it will try and do that, and that is blindingly fast if it's inside of it. I mean, you're talking like seconds to actually crack that because it's a sorted list. Use the default credentials. I'm not going to insult your intelligence. Google is your friend at this point. There are lots and lots and lots of them. If it's vulnerable to Cypher 0, we can just reconfigure it. So what do we do after we smash the box? Basically, we need to accept that the hardware itself is compromised. It's not the OS, it's the hardware that's gone. We know that we have direct memory access and we have the ability to perform memory corruption. That's a bad thing. What memory you can interact with is going to be dependent on the interface you've got with it. And yes, there are alternatives to do it. One of my most enjoyable techniques is to, if the customer is willing to let you do it, is to actually bounce it into another OS. And at this point, virtual media becomes a really good thing. So credentials harvesting, on one case, we found a Lightsout management that was vulnerable to IPMI on a domain controller. So loaded up off-clock Vive to the virtual media, went into the baseband management controller, reconfigured the boot order, so we changed the BIOS to where it would go from, we bounced up, grabbed it out from there. Fortunately, it was a bog standard Intel NIC, so we could just squirt the hashes straight off the off-track live virtual media, and yeah, that was every single hash from the domain controller. 15-20 minute activity. It was quite a nice one to demonstrate to the customer. That was fun. This one I enjoyed even more. This one was an Exchange server, and for the Exchange server, when we bounced it into a live Linux environment. We deployed a copy of Metasploit service. First time I did it, it got squashed by the AV. That angered me, so I rebooted it again and replaced the Sophos service with Metasploit service, and then brought up the Exchange server. That was nice, because as soon as that came up, I got my Metasploit session coming back. And I thought, oh, that's pretty cool. What I didn't necessarily understand as I did it was just how quickly every single email client in the entire environment wanted to talk to the Exchange server that had suddenly gone offline. And so we got all the hashes getting thrown straight back at us. It was very much like Christmas. Everyone happy? How do we do it? What do we use? So we need some tools to access the Lightsout Manager. This is a really customized set of tools. You need to be very careful about where you get these from. You need an old browser. Basically, Java runtime environments make extensive use of both JNLP and Java 1.4 plugins, and basically jars that are not nice if you try and play with anything more recent. So you are going to need to basically degrade your security to get it working. I've had very little success, as in zero success, getting either IE 10 or 11 to work properly with pretty much any of the Lightsout managers around there. Firefox does seem to be slightly better, but it's much of a muchness. You'll need to be able to telnet and SSH into boxes. I'm hoping this is all your standard toolkit. Oh yeah, almost always telnet rather than SSH. I don't know why. Very few of the manufacturers actually configure it to come up, configure any of the management controllers to come up with SSH active by default. IPMI client tools. We're going to be playing with IPMI tool, and we're going to be playing with BMC config. They're easily available to get hold of. We will be giving you some pre-compiled versions at the end of it. The other one that's really useful to play with is the Supermicro Java's implementation of IPMI. It supports IPMI 1.5 and 2.0, and is pretty much the best reference client you're going to get if you want to connect to any other bit of kit. It's a 90 meg download. It's trivial. It's really worth having access to. Your biggest problems. If you've got mismatches inside your libraries, you're going to get false negatives, because basically you're going to fail the crypto steps, and you're not going to know why you failed those crypto steps. The ones that hit us each time is libcrypto, and OpenSSL. There are magic combinations of those three, plus the version of IPMI tool or BMC config, which works. Others don't. Most of the tools that we look at are generated just for NIC systems. Talk about that in a few seconds. Status support in the normal toolkits. Let's talk about Kali first, because everyone likes to play with Kali. It's been broken loads of times through 104 and 105. Don't even bother looking at backtrack. It's just not there. As of a little while ago, it was working. Update any of your libraries, do an update of your package. You may not be successful. One of the things we find very useful is to statically compile the tool, so that you're then no longer reliant on the libraries. Yes, it makes a bigger XEs, but they work, and I can trust them, so I like them. CentOS, it's considered to have a security vulnerability, so therefore it's not supported. I agree. Debian Ubuntu, basically it's broken pretty much everywhere. I've not had much success getting it working on Debian Ubuntu, Mint, and all the rest of it. There seems to be some kind of catch inside of that in terms of Kali, but hey-ho from there. The biggest false negative you'll see with it is the RMCP connections, which is the encrypted string that goes backwards and forwards, fail, and that fails your authentication. That RMCP is calculated even if you're using Cipher 0, so it's the library issues that's causing you the problems from there. Anyone want to see some demos? Start with the old school stuff. How do we find it? HTTP 663 is a map. It's really not that difficult. Yes, note that open filtered is really, really common. Don't assume that necessarily means it's closed. If it's IPM on a shared NIC, ports can say it's closed. The OS is lying, and BMC is going to reply to valid ones. So basically what you're going to want to do is you actually want to poke IPMI tool at it, or you want to poke BMC config at it and see whether or not it responds. And you'll get more information by looking at Wireshark and just have a play. Cypher 0, we've mentioned it a number of times. Fundamentally, one of the challenges was when IPMI 2.0 was released, they said, okay, look, we had no crypto before, we should apply cryptography, it's best practice. We know that cryptography is hard, okay? So let's set the very first cipher that you can select to be no crypto at all, yeah? Makes sense? In that circumstances, we need to understand that sending our creds over the wire is going to be a bad thing. So let's not do that. Let's just disable the authentication and trust that the username that the user has supplied is a valid username. I don't think I need to say very much more, do I? So how do we do it? So in this case, we're attacking a iDrag box on a piece of Dell kit, and we're logging in with the default credentials of root and Calvin. In this case, if I try and connect with a wrong password, no joy. And if I enable Cypher 0, joy. It really is that simple. BMC config. BMC config has a little bit more functionality. Not only can you tweak what's going on inside of it, but you can actually reconfig the box at the same time. Technically, it's not IPMI, but it does support LAN+. Now, LAN+ is IPMI 2.0 because it's LAN+, it's the next version. But it also provides Cypher 0 as part of the standard. LAN+ is implemented as a driver, so we use this -i syntax as opposed to the C0 syntax. It's actually implemented as the driver LAN_2_0. Be really careful of that second underscore. It has bitten me so many times because almost all the documentation says LAN_.0. It's not. It's __. Not that I've ever got irritated by that. BMC config with the -- checkout. So basically saying to the baseband management controller, tell me how you're configured, and how I can reconfigure you. And so basically in this case, what we're doing is showing you what a configuration of the baseband management controller looks like. If I use the wrong password, and sorry, -i is the crypto. It will spit out the config, and if I prove that there's nothing up my sleeves, it fails you from there. Happy days? So why do we want to use the reconfigure? Well, reconfigure is probably the easiest attack you can use. You can use the checkout to actually dump you out a file, to a text file, and then you can hack it. But that allows you to have a pre-hacked and a post-hack state, so you can reverse your actions afterwards. And as a professional pen tester, being able to undo an action once you've done it is quite a nice thing to be able to do. Generally use a text file to do that, so in this case it's context IPMI. In this case it defines a user of slot 3, and username is context, password of yada 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 yada. All good stuff to do. First thing you need to do before you actually try that is to actually dump the config. And the reason I say that is different manufacturers have a different terminology for no access or restricted access or whatever, or like the admin role will be different named inside of it. If you dump the config first, it will tell you what a supported configuration option is. Otherwise, you're likely to just be guessing. The 4 options there are not equivalent from an IPMI perspective, so you need to make sure you're using the right one for the implementation you're looking at. So in this case, we're just quickly dumping out the users on a box, and I've added a new user, and we can see that because the new user's there. The user that was added was slot 3 user context, as you saw by the context.ipmi file. IPMI file. Happy days? Some worried looking faces. It's okay, it's fun. Okay, Dell iDrag. I need to mention Dell iDrag because it is a bit of an edge case. Basically, there's 2 flavours of it. There's the enterprise flavour and the light version, or express version. The edge case we care about is only inside the enterprise grade kit. If it's express, it's the same as everything else, and you don't need to worry about it. Inside iDrag, there's basically a combination. It's basically a dedicated card that is attached to the motherboard. It provides you your service controller, baseband management controller, and the IPMI interfaces, and a web server, and a SSH server, and quite a few other bits and toys inside of it. It's got an administrative GUI, it's a web GUI. Yeah, it does all the normal kind of tricks around that, and I'm sorry, this is a really fuzzy image, but hopefully you get to see a little bit what's inside the enterprise kit. Bits that I like more than anything is the ability to snoop what's on the screen of a machine. Is it going to come up? Patience isn't the virtue of mine. So the black box top right, unfortunately it's not very easy to see on the screen, shows an ESXi screen at log on. If that was a Windows box, obviously you have your Windows console, anything else going inside of it. Yes, we can enumerate details about the system, so we can make sure we really should be hacking this box and it's not someone else's. You can look at the status LEDs, and then you can look at various ways of reconfiguring it. So in this case, we could change the first boot device to be a virtual CD-ROM and ISO. We could upload a new virtual CD-ROM and ISO. You can probably guess how the kind of attacks we just described have been facilitated previously. Generally nice to reboot with a warm reboot as opposed to a cold boot, but mileage may vary. And there is, somewhere inside of here, the ability to fire up the virtual console, which is VNC. I'm really sorry, that resolution is horrendous. The slides will be available, the videos are inside the slide deck, so you should be good to go from there. And vFlash is virtual media, so you can upload ISOs of your choice. We need to be aware that IPMI, so changing configuration things for IPMI does not necessarily have the same effect under iDrag Enterprise. And the reason for that is that the iDrag Enterprise users are not have an additional property assigned to them that's not there when you just assign them via the BMC. So the context user we added previously won't work, and in this case it's because the iDrag privilege has not been assigned to user slot 3, which was the administrator. Basically going through from there. Have a play with an iDrag card. If you've not seen it before, you just need to go and enable it. The techniques we've looked at previously in terms of adding a user, reconfiguring a user, they work pretty much everywhere else. It's this iDrag Enterprise, it's the real problem. But there is a simple solution. We can reconfigure the root user. We could just set our own password. Who cares? So in this case, what we're going to do is say, okay, look, dump out the user list. In this case, the root user, the administrative user, is ID 2. And what we're doing here is we're setting the password for user 2, the root user, to a really strong password. And in this case, what we can then do is, I get in the habit of using Cypher0 too much, I'm sorry about that. We can attempt to log in with the real credentials, no joy, and then we can prove that actually our password has been changed. 1, 2, 3 from there. Nice and easy one to go through from there. Easiest way of confirming it, definitely using IPMI. If you're really boring, you can use the web console and you can just log in. Because the root user had the iDrag privileges, I'm now able to use the 123 password that I just compromised to sign myself into the iDrag and do good things from there. Everyone happy? Do we actually need iDrag? It's a really good question. If the BMC is failed over into shadow mode, then you're not going to have iDrag. It's not going to be presented for you. So it'd be really nice to know how we could do some of those techniques. Now, I mentioned before that the LOM environments provide a zero installation client, and that's basically all we're really worrying about. iDrag Enterprise provide for us. Yes, we can do some checking around that one. We can do a lot of this with IPMI itself. Now, the easiest way of doing that is with a Supermicro client. Now, I'm not going to insult your intelligence. Download it. It's a jar file. Run it. Basically, we can log in from there. Now, at this point, what I'm going to do is I'm going to log in with the context user that I created previously. The Supermicro client doesn't provide you with Cypher0 support. So I've not found an easy way of enabling it. So if someone can, that's great. If not, so be it. So just logging in from there. And bottom left, it says RCMP plus open session successful. That's the crypto bit being going on from there, and that's where your libraries are dependent. This is also one of the reasons why the Java implementation is awesome, because all the libraries are stuck inside the jar file, not reliant on your system ones. We can connect to it. We can see all sorts of really nice instrumentation from the BMC. We can make the front LED blink if you really want to. One One thing I will say is, if you notice how slow this is to respond, this is because basically you've got a little baby ARM processor running in the background, desperately trying to get this instrumentation information whilst we're asking it to do other things as well. We've been really outrageous to it, but hey-ho. And you can reboot it, you can reconfigure the IPs, you can do all that kind of goodness from there. Depending on the DRack solution that's been deployed, or at least the Lightsout management solution that's been deployed, will give you GUI redirection, all that kind of stuff inside of that, but it's going to be on a case-by-case basis. There is no one, I can't give you a generic statement that says this will always be true. We're pen testers. We use Metasploit, don't we? Can we use Metasploit? Yeah, of course we can. Basically, the HDMore has re-implemented the IPMI protocol as a Ruby protocol. Sorry, I'm jumping on very quickly. And it's got a whole load of stuff inside of it. You can crack passwords, you can dump it out from there. Go from there. Very quick with this one. So your default configuration, it will dump your passwords and we'll crack them. If we exploit it, yes, it'll dump the hash, yes, it cracks the password, but that's basically good to go from there. Quick couple of freebies for you. We've compiled up under Cygwin both IPMI2 and BMC configs, what I was using for the Windows prompt almost all the way through. You don't have any worries about library linkage and all the rest of it, because it's all pre-provided by a zip file. And it's really good if you're on a Windows box, because you can take one and then grab the management network of everything else on the back end of it. It's going to be available on our website shortly. I believe it should be there now. If you're wanting to play with Intel stuff, the AMT stuff is all available from Intel. Now, I've got a very quick demo if you guys want to see it. It raises, no, really sorry guys, apologies for that.